What's up, Larry? What's up, Steve? Afternoon. Bit of a random time for a stream, but I've got a bit of spare time today by myself, so I thought I would turn on the stream just while I'm fanning about in the workshop. What have I done with my multimeter? Give me a sec. Where have I put my multimeter? I took it out yesterday. Ah, here it is. I took it to purchase a subwoofer off Facebook Marketplace yesterday just to check that the coil zoned out. So I had it in the car, so I just have to whack it back on the bench. Here we go. Let's get the multimeter camera hooked back up as well. Get that plugged in. There we are. Let's go for snake cam. There we go. Get that up and running. What's up, Ronnie? What's up, John Joseph and Fisher? Man, a few people on in the afternoon on a Tuesday. Thanks for jumping on. Oh, what sub did I buy? I will show you. Let me show you. So yesterday, a friend of mine sent me a Facebook Marketplace link and said, "Yo, Sam, check this out. You need to check this out." So I had a look, and on Facebook Marketplace there was a guy selling 2 Pioneer subwoofers with 2 Kenwood amps. And I scrolled through the pictures, and this was one of the Pioneer subs that was being sold. This is the TSW306C. So this is a 400 watt RMS, 12 inch with a single 4 ohm coil. I think it's like a 2.5 inch coil. This is not a bad budget sub though, to be honest guys. This is actually a really nice sub for the money. You can pick these up from Facebook Marketplace or eBay super cheap. They're probably better than the Sony Explodes actually. Yeah, massive thick tinsel leads. Look at the size of the tinsel leads in this. That's really big tinsel leads for this size woofer. The magnet is like a fair size. So this was one of them. And this one's in okay condition apart from a couple of scuffs on the surround. It's got this weird cum stain in the middle of the freaking cone here. The cone also has a little bit of a crack, which is a shame, but it won't affect it. It's just on the dust cap here, so I could glue that shut from the other side. I don't know if the camera will even make it out. Oh yeah, there you go. It's very fine, just a little crack. So that was the first one, but that wasn't the one that I was interested in, guys. The one that I was interested in was this one. 121 SPL. And the guy didn't really know what he had, so basically this guy was selling this sub, that 306C and 2 Kenwood amps, and I got the whole lot plus some cheap prefab boxes for £80, 80 GBP. So I'm well gassed about that. The guy didn't even have this hooked up properly, this 212 SPL. He had one coil connected. So, and I think the amp he had it on was this Kenwood amp, which is like a 4-channel. So it's probably getting like 70 watts on one coil for its whole life. So it's been barely used. It's in pretty good condition. The dust cap has a couple of kind of creases on it, but I think they do tend to get that. Like, I don't think that's like happened in ownership. There is actually a bit of a crease there where something's hit the dust cap, but all in all, not bad condition. So I now have 3 of these bad boys. I have 3 of them, and I want to do like a retro nostalgic build in the Proton. So I've got 3 so far, and we'll see how many I end up with. 3 would be a nice number. I think 3 would look really nice, like in a line or in a triangle shape or something like that. Just like on an SQ build. So yeah, really gassed about that. And the amplifiers that came with that bundle were this one here. This is a KAC 9152. So this is a Class D mono 900 watt RMS 2 ohm monoblock. Yeah, pretty nice amplifier. I think it benches around 1100 watts RMS, so that was pretty good. And then the second amplifier that I got in that bundle was this one, which is very beaten up. This is a KAC 846. This is a 4-channel. Probably quite a nice sounding 4-channel, but it looks a little bit dead and empty in here, not gonna lie. So what I was gonna do, I'm gonna sell all this other stuff. I'm gonna sell the 306, I'm gonna sell the sell that mono, sell the 900 watt mono, and I'm also going to sell this as well. But I just wanted to like take the top off and just check that everything was okay in it before I set it, because I'm like that. I want the new owner to have a good experience and for there not to be any underlying issues like broken ground traces. In this Kenwood mono, in this one, there was actually a broken ground trace for the RCA ground to main ground connection. So I fixed that. So whoever gets these amps are going to get, you know, fully functional, top, you know, fully checked out working amps. So yeah, one of the things I just want to double check is that there is a good connection between the RCA signal side ground and the main ground, if there is supposed to be one. So let's have a look. We got 12 volts coming in there. That's our ground. There's no short between 12 volts and ground. That's good. Okay, so RCA ground to main ground is not directly connected. Do we have like a 1K or anything resistance between them? Sometimes you do. Let's just get my camera here kind of lined up a bit better. So let's go on the RCA ground and main ground. Okay, yeah, it looks like we've got 1 kilo ohm between the RCA ground and main ground. That looks intentional. So I'm going to clean all the switches on this. Guys, what happened to the stream? Did the stream cut off? Where did we get to? The stream cut off? Is it working now? What's up, Seddon? Yo, Rat Green. Did the stream cut out? 2 people, Jason and John, said the stream ended, but okay, maybe it didn't. But yeah, anyway, so I got 2 Kenwood amps and 2 Pioneer subs. Stream dropped, okay. Well, anyway, like I said, I got a Pioneer 306C and a 212 SPL, which I'm really excited about because I've got 3 of them, so I'm going to do a retro build in the Proton with the 3 of them. And I got a 900 watt RMS Kenwood 2 ohm mono and whatever this thing is, KAC 846. So I'm just going to check that this one is fully functional, doesn't have any broken ground traces. I've just measured 1 kilo ohm between the RCA ground and the main ground, so that's good. I'm just going to power it up now and just clean all of the toggle switches on the side, because the toggle switches are known for going bad on these. So just to get better access to them, I'm just going to unscrew this and get better access to the toggle switches so I can give them a good old clean up. But how's everyone's week going so far? Boom or bust when? I don't know, man. I don't know. Boom or bust is only really worth doing if the videos are going to get sort of over 30k views, which they weren't. So I don't know, man. So let's just have a quick cheeky peek at the preamp board here. Take some isopropyl alcohol, spray it all up in these switches here. There's 1, 2, 3, 4, 5 toggle switches on this amplifier. So I'm just going to unplug the preamp board here. There we go. So I can get to the switches a bit easier. What's wrong with this amp? Well, nothing so far. Nothing really, I don't think. I'm just giving it a service because it's one that I've bought that I'm going to sell on. So I'm just giving it a quick little service. Just checking the continuity from the RCA ground to main ground. We've got 1 kilo ohm, which is what's intended in these. Just cleaning up all the switches. You know what, guys? I say this switch cleaning tip probably like at least twice a day, at least like 10 times a week. So I have it saved in my phone just as a pre-typed out message that I copy and paste. Because people message me saying, oh, my amp is powering up but got no sound. Or oh, the sound on channel 1 or channel 3 is like not there, or it's cutting out or something like that. And 9 times out of 10 it's these switches. So just spraying some isopropyl alcohol and flicking them backwards and forwards plenty of times, which cleans the contact rails inside the switch that get oxidized and dirty, and that usually sorts it out. Go, and let's just do these two over this side. Good morning, Aaron. How's it going, buddy? Daytime live repair, exactly, Matt. Daytime live repair. So the rare boy, the rare daytime repair stream. You made it. You made it for the daytime repair stream. So for today's stream, we're going to be looking at this Kenwood, just making sure that it works, and then provided it works, we can either look at, I know some people are going to be annoyed because I'm sure they wanted to see it, and I usually do an evening stream. We're either going to be looking at these JL Audio donor boards and spare parts that I got given that I went through on the last stream I did. Basically, I got donated a whole bunch of JL Audio kind of boards and heat sinks and stuff, and we're going to try and make some working amplifiers out of them. So I might start having a look at those and seeing what works, what doesn't, what needs repair, work, etc. Right, let's get this back in here. And then we can just put some power to it, make sure it powers up and get clean audio on all channels, and then I can sell this. I think this is supposed to be quite a nice amplifier, this. The old Kenwood 4-channel Class AB. It's got adjustable bias, which is a good sign. I thought you was nocturnal. I used to be, bro, but I've grown up a bit since my early streams. I'll tell you what, actually, doing live streams like years ago when I was single, when you're single, you don't really care about the time of day and stuff. So I used to stream till like 5 AM. I used to start streaming at like 8:30, 9 in the evening. I used to be streaming till like 3, 4, 5 AM. Those were the days, but yeah, when you get yourself a partner and you start getting into a proper routine and stuff, then those kind of late night activities become less convenient. All right, well, that's that. Let's just put some power to it and see what it does. The guy did say that this was fully functional, so I'm not expecting there to be any issues, but you never know. Oh, Aaron, that's hardly juicy knowledge. She's been in one of my videos. If you watch my video of the Digital Designs M4000, I did a review of the new Digital Designs Half Bridge M4000. She does a hair trick at the end, towards the end of that video. Okay, so we have power, ground and remote, and let's just grab some RCAs. If the board doesn't have adjustable bias, then that's Class B, not Class AB. Well, Class B is kind of Class AB without much crossover, essentially. Basically, if it hasn't got adjustable bias, then the board designer or the factory will have kind of set a low bias point, but that's been calibrated to the batch of output transistors or the model of output transistors that they'll be fitting for that run of like 1,000 amps or whatever like that. So they basically just set the bias fixed to a pretty low bias point, just to account for any sort of batch differences or tolerances between the parts. So yeah, usually if it's got a fixed bias, then it will have pretty minimal you know, overlap between the transistors. Okay, so a little bit of power. Make sure we get no current draw there. Turn my signal generator on. And let's power up. Actually, let me just turn the gains down on this. I don't know what the gains will be set to, but oh, they're set really high. It's typical Facebook Marketplace purchase. Okay. So we have 1.2 amps idle current draw. Let's check for audio. Okay. So not getting anything just yet. Okay, so we have audio there and audio there. Fantastic, nice clean sine wave. And then if I flick this switch to clone input A onto input B, then we should also get, there we go, some signal on there and there. Oh, hang on a minute, that's not really looking so great. We've got a very different amplitude sine wave. That's a problem. That's something we need to look into. See, this is what you get if you buy a used amplifier from me. You know it's going to be absolutely 100% because I check for all these issues, whereas nobody would check for this. Like, so on channel B, on the sort of B set of channels, we've got a very different amplitude sine wave there. So I'm just going to toggle these switches around and see whether it's a dodgy switch that's maybe causing that. So it's not the one that clones the signal because that's not really changing the level there. How about stereo left right mono? No, that's not doing anything either. High pass low pass filter switch? No, that's not doing anything either. About the one over this side. Okay, that is adjusting it but not really changing it much. How about this one? No, that one's not really getting it back to full output either. Okay, so there is a bit of a problem there then. Filter off. Yeah, there is a bit of a problem there. Okay, what I'm going to do is I'm going to remove the RCAs from input A, and I'm going to just put them directly into input B and see whether we still have the difference in amplitude. Yeah, we do. So it's actually an issue. Oh, actually, no, what? Hey, that's not even clipping. That's not even clipping evenly. Oh man, this amplifier is certainly not 100% happy. Right. Interesting. So on the channel that looks like it's lower, it does clip evenly. However, the channel that's a bit too high is clipping unevenly. Right, let's just flick through the crossovers again and see whether anything changes. I suspect we have a preamplifier fault here. This looks like a preamp issue to me. You see, you get an amp sold as functional, as fully working, and it turns out not to be. Alright, let's go back to channels A. So A left and right do clip absolutely dead evenly on that one and also on that one. So let's turn our attention back to channels input B. So that's our issue there. And I don't think, let me just give the gain knob a little twiddle around just in case like it's a bad potentiometer, just needs a bit of a clean up there. No, okay. Right, so we are looking for a preamp fault then on inputs B. Typical. Did you fix your error 70? Oh, well remembered, Matt. Yes, I did. I don't know what it was. I just removed the camera, I put a battery in it, left it for a bit, and then it just turned straight back on again. So I don't know what that issue was all about, but yeah, it kind of fixed itself, so that's good. So basically, what we have is we have a dodgy looking sine wave on input, where is it? Over here. Right. So we need to find that same sine wave elsewhere in the board, and what we want to do is see whether it comes out of the preamp anyway. Now the preamp, it passes its signals on from the preamp board to the main board via these jumpers here, these wires. So I'm going to be basically going through each of those and looking for a wave that looks similar to that. Now basically, because this is the preamp, the only DC we should ever see on any of these little wires is just plus and minus 15 volts. We should only ever see one pin for plus 15, one pin for minus 15. If we see DC anywhere else, then that means that there's a leaking op amp or something bad in the preamp circuit, because there should never be any DC on any of the signal paths. So we have, okay, well we have -5 there. Let's just take that for reference. Nothing on that one. We've got -1 there. That's not looking promising. Then here we have a big ass sine wave. Okay, well look, there we go. There's our dodgy sine wave that's getting amplified. So it's definitely a preamp fault. Okay, it's there as well. And you know what? I'm actually wondering whether this might be a feedback issue. Right, there's our... Right, I've got -28 and +29. So basically the rails are coming straight into the preamp board, okay? And then there'll be a regulator on the preamp board itself. We've got +5.5 there. There's another sine wave. That's for the other channel. So we can take a reference. Okay. So that's the good channel. And the dodgy channel is over on this set of terminals here. Right. So, just because I've had a bit of experience with these Kenwoods before, this might not actually just be a preamp fault, because I've seen this before where when there's a issue with the kind of feedback from the main amplifier board to the preamp board or to the sort of drive circuit, you can get this behavior. So what I'm going to do is, just because this is a single-sided PCB, I'm going to take both of these boards out and just check on the underside of the boards for any sort of cracked solder joints or any cold solder connections, because that's pretty common on boards like this. Single-sided PCBs, there's a lot of leverage from the top onto the solder connection and it can crack it. So I'm just going to take the main board entirely out and have a good old look and see if there's any obviously bad solder connections or anything like that. Let's get this out again. There we go. Pop that to one side. Let's start unscrewing all of these from the heatsink. How many cameras do you have set up for this stream? Says Rat Green. So at the moment I have obviously one here. I have 2 up here, 3 on the multimeter, 4 on the scope, 5 on the power supply, which actually, oh yeah, 5 on the power supply. I think that's it for now. I did used to have like 8. Yeah, that's it for now. I've experimented in the past with like other camera angles for various different reasons. But this tends to work fine for now. The best camera angle that I ever experimented with was a soldering iron cam. So basically I had my soldering iron and I actually had a little camera pointing like kind of down onto the tip, and it was focused on the tip, and so it would follow around while I was holding. That looked freaking awesome, but it was just really clumsy for me to hold. It was like a bit inconvenient. So, but I might revisit that because it did look really freaking awesome. Long time no see, BTRX. How's it going, man? Yeah, really cool to see you. I love seeing people that have been watching for years jump on the stream. PCB weight ads have been burned into my brain. Now, every time you say PCB, I have the response. Right. I see. Well, sorry about that. Let me say something else. Let me say circuit board instead then. Oh, the hat cam. Yeah, the hat cam's good. I do have the hat cam still here. Wait, what did I just do with that piece? That. Hang on a minute. I just took a bit out of here. What did I do with it? I do still have the hat cam, but I haven't got it hooked up at the minute. Some people say that it makes them feel a bit dizzy, so I can try and get the hat cam plugged in for today for you if you really want. How many people want the hat cam today? The only reason I'm not using it is because the USB-C extender wire that I've got plugged into the back of the PC doesn't actually seem to be connected, because I plugged the hat cam in and then the camera doesn't show up, so I guess my wire is like slightly not plugged in or something. I can try and plug it in. But this is basically the hat cam, just without all the motion sickness. How's the stream quality, by the way? OBS is telling me that oh, hang on a minute. OBS is telling me that it's a little bit unstable. How are you controlling the stream cams? Rat Green, so basically I have under the desk I have a set of 3 USB foot pedals. So I've got it's just a set of 3 pedals that are connected by USB, and you can assign them to hotkeys. So I'm using OBS obviously, and then when I press each of the pedals, I have that pedal button set as a hotkey for each OBS scene. So this is scene 1, this is scene 2, this is scene 3, and then I have, in addition, I have on the bench, I have a little set of buttons that are some additional buttons. And this one is the screen capture. And I also have some sound effects like that I never use. I programmed a bunch of sound effects. Like if you get something right, it's like, or if you get it wrong, it's like, or you know. And also got an explosion as well, just to screw with people. But I never use that. I always just forget to use that. Hello Nista 6000, what's up buddy? Good morning JD, good to see you. Oh man, I was really hoping that there's nothing wrong with these amps. I wasn't really planning on repairing them, but having to repair. There you go. You never know what you're going to pick up from Facebook Marketplace, so So basically, OBS is currently telling me that the stream quality is quite low. You see down here, kbps, it's fluctuating around. I'm getting like 20,000 kbps, which I shouldn't be. It should be locked at like 8,000 or 6,000 or something. Let me just go stream output. So I should be locked into 8,000 with a maximum of 10,000. Let me just drop that down to 6. See if that helps. I'm currently using Wi-Fi. I do have a LAN cable for this setup up here, but I don't have it plugged in at the minute just because of convenience, but I could go and plug it in if the stream quality doesn't seem to be that great. Yeah, it seems to have settled in a little bit better now. 8,000, there we go. Let's see how that goes. Is this one of your personal amps? Yeah, I guess so. So basically, if you didn't catch the start of the live stream, yesterday I went and picked up a few bits off Facebook Marketplace, including a beautiful old Pioneer TSW121 SPL that I'm going to be using in the Proton. I've got 3 of those now, so there's going to be a build of 3 of them, or maybe more if I can find more of them before I do the build. As part of the bundle that I bought off Facebook Marketplace, there was 2 Kenwood amps included. This was one of the Kenwood amps that was included in the bundle that I had to buy, that I'm just going to sell on, and I was just making sure that it worked, and turns out it's actually got a fault on one of the channels, which is a pain in the ass. So I wasn't intending there to be any faults, obviously, with any of the stuff that I picked up. I trusted the seller that it was all working fine, but I guess sometimes it's hard. Okay, so if we take a look on the back of this PCB, I am seeing some hints of like sort of cold solder joints. So if you can see here, don't know if the camera will make it out too well, but some of those solder connections, I'll zoom out a little bit, look a little bit cracked. So that's the sort of thing that goes wrong on these amps and can cause these kinds of weird issues. So I'm basically just going to go around now with the soldering iron and reflow a bunch of joints, any ones that have like a little circular thing on them that look like they might be sort of cold joints or cracked a little bit. There's actually loads of them I can see. Like I said, I don't know how well the camera will make them out, but I've spotted quite a lot of them that look like they could be poor. So yeah, let's grab the soldering iron, just go around all of these, and if that fixes it, then that would be great. If not, then we'll dig a little bit deeper and see what we can find. Right, bit of solder. And we're going to start on these. Now these ones I saw first, which is interesting. Those are actually the wires that lead up to the preamp board, which might actually explain the sort of feedbacky type issue we were getting with the uneven clip. So I'm going to reflow those ones first with some fresh 60/40. Yup. And then these ones as well. Yeah, just take your time, guys, you know, it's chill, isn't it? You're just chilling here, chatting to your mates, reflowing some things, having a great time. You're not sitting in the office, you're not answering calls, you're not talking to some bullshit customers, you haven't got management breathing down your neck. You're just chilling in your own workshop in the comfort of your own house, got your tunes flowing, got drinks and snacks at your disposal. You got the freedom to pop out when you want. You can bang on some YouTube videos and catch up with some social media stuff while you're working. I love the self-employed life. Can't lie to you. It's good. Is it the most lucrative job in the world? Absolutely not. Could I be earning 10 times what I'm earning now by knuckling down in an office? Probably. But where I'm not rich financially, I am rich in free time. I am rich in relaxation, no stress, free time, freedom, flexibility. That's what I'm rich in, guys, and I value that. Obviously money's important, you've got to be able to support yourself and live comfortably, but if you can live comfortably and support yourself, and value freedom, value your freedom, value your flexibility, and that's one of the keys to happiness, I think, guys, to be honest. A lot of people that are mad rich, they got a bunch of shit, but they're not necessarily happy. I ain't got a bunch of shit, but I'm pretty happy, not gonna lie. This connector up here is kind of bad. That's got a really bad solder joint, that has, and doesn't really seem to be reflowing too well. It's kind of oxidized, so there we go. That's a bit better. Yeah, there's loads of little solder connections here that have little circles on them, which means that there's been a bit of stress on their solder connection. So we're going through each and every one. Ma'am, I will tell you each and every one. Yep, okay, I think most of them are done that side, a couple over this side. Oh yo, Josh, man, thanks for the 8. Greetings from the States. What's up, my man? Josh Kite, thank you very much for the 8, buddy. If you've got any questions or any stuff you want to ask me, let me know. Suck the solder off, sand the pin, and then resolder with flux if it ain't sticking. Yeah, exactly. That would be the right thing to do on this one over here. As this isn't actually this one's not critical, but see this solder connection over here. That is for this little bar here. So that's not actually connected to the circuit. I think that's just a bit of solder for mounting purposes. But yeah. Sand it down, plenty of flux, and that makes a much better connection if it's critical. Go. Any more over this side that look kind of bad? Most of them look alright, to be fair. There's just a couple here and there that have little circular cracks on them. Radial cracks. Radial. That's a good word, isn't it? That's a word that I should use more often. Words are cool, aren't they? My uncle's kind of funny. My uncle lived by himself. He found himself with a lot of free time. And he read through the entire Oxford English Dictionary. And then in conversation, he would bust out these next level freaking words that no one's ever heard of. And we'd be like, what? What does that mean? He'd be like, oh, it means this. I'd be like, well, just say that then. Because he'd read the dictionary. He had all these next level, like, freaking words for things. I actually always like, I like discovering words that they have in other languages for things that don't exist in English. I think I always find that fun. Japanese and Chinese has a lot of things like that, just where the cultures kind of develop differently. Like there were some things that just don't translate, or that you need a whole freaking sentence for in English. I find that kind of fascinating. Like I think that's where it'd be cool to be bilingual, because you could use all these kind of words and stuff that describe a specific emotion, or where you're feeling, or a certain circumstance or something, that describe it perfectly in like one word that there isn't a solution for in English. I think that's kind of cool. Does anyone know anyone that's bilingual? Like, so basically, one of my friends, he's British or South African, and he married his wife who is Italian, and so when they brought their kids up, basically he speaks to his kids in English, and his wife will speak to her kids in like Italian and English. So the kids have basically grown up with Italian and English both at the same kind of level, and so they're fully bilingual. And so when you go around to the house and like the kids are like talking to the mum, they start off in English and then they're like just transitioning to Italian like halfway through the sentence, because it sounds better, or whatever they want to say works better in Italian, and then they'll go back to English again for like something else that works better in English. And it's like really crazy and really cool to see. Alright, I think that is all of the joints that I was a little bit suspicious of. So we're going to flip it back around and plug it back in. I mean, I don't know if that will have solved it. Like, there is a chance that that's fixed it, because that kind of waveform that we were seeing on the scope does lend itself to like a lack of feedback from the output section to the preamp in how these amps work. But I don't know. I'm also just going to check the same kind of thing on the little preamp board here, although there's less chances for it to be up here, I think, just because there's less there's less like massy components that have leverage on these solder joints. There's a couple that look like they could do with being reflowed. So alright, Aaron, thanks for the 5, man. Off to work, have one on me, man. I really appreciate that. It's kind of you, buddy. Thanks for jumping on for the time that you did, and I hope you have a good time at work, and yeah, hope to see you at some other point on the streams. Chocog the best, or whatever that says. I have an amp that breaks head units RCA outputs after 3 to 4 weeks of working fine. Oh man. And after changing the head unit, it starts working again. Oh man, that sucks. The only thing that I can really think of, okay, is, let's say, I see that wouldn't break the RCAs fully. I was thinking, let's say that amplifier has a intermittent broken connection on the ground terminal on the board. Okay, So the amplifier's powered up, it's got 12 volts and remote, and it's playing on the sub, right? That's fine. Let's just say that the ground connection then just breaks a little bit, you know, disconnects from the board. Now the amplifier does still technically have a ground reference down the RCAs, so it's still trying to make power to the sub. So basically all of that current that would have gone down the power ground is now trying to work its way down the RCA ground, and that might be blowing the ground trace in the head unit for the RCAs, you know, for the RCA outputs possibly. So that's the only really thing I can think. I mean, apart from that, maybe if the amplifier has leaking or bad preamplifier op amps that are leaking DC into the signal line in the amplifier, it could be making its way back up the head unit. But usually amplifiers will have DC blocking caps between the RCA inputs and the first op amp to mitigate these kind of issues. So unless it's not got those, and an op amp is leaking and is sending like 15 volts or whatever down the RCAs to the head unit, that could cause it. But yeah, it's weird that it works fine for like a few weeks and then dies out. That's why I'm thinking it's like some intermittent connection, that when it actually breaks, then it's killing like some ground trace in the head unit. That's the only thing I can really think of there, buddy. Hello Rick, how's it going? In reference to your soldering iron cam, look at USB endoscope cam, £5 on eBay. Yeah, that's what I had connected. That's what I'm currently using for the multimeter cam here. It's like a little endoscope cam. The problem is that I would absolutely need one with autofocus because of the distance. Well, maybe I wouldn't. Maybe if I got a fixed focus one, I could just like have the camera like situated at the perfect point where it was always in focus. Alright, maybe I'll try it. I'll get a really cheap one. I'd want it to look half decent. I wouldn't want it to be like 10 frames a second, you know, and like 480p or something. But I'll check it out. I'll have a look. So let me just go through a couple of the solder connections on the back of this board, on the back of this preamp board. Like I say, most of them look absolutely fine, so I don't really think there's going to be an issue up here. But might as well while we're here. Yeah, there's a couple over here actually that don't look too great, so it's probably a good job that we did go through these. To be honest guys, any time you pick up a really old amplifier like this that's single-sided PCB, if you've got a soldering line, just take the board out of the heatsink and just reflow any solder joints that look like they are a little bit cracked, because it's so common. Like, guarantee that an amplifier made in the 90s, that single-sided PCB, by this point in its life, with all the road vibrations and audio vibrations, it's going to have at least one broken or bad solder joint somewhere in it. It's bound to be there. So if you do want to be buying old amps to use them, then yeah, definitely pull it out of the heatsink, go over any joints that don't look great. Dude, with a 20! 13 BT arcs, fuck man, that's a lot of money, thank you very much. Holy shit, this afternoon stream is starting to pick up financially. I might have to do these afternoon ones a bit better. Thank you very much, my man. What's your opinion on stereo integrity SIQ amplifiers? Oh, fuck, I wish I could answer this for you, man, but I have never had one of those on the bench. Let me have a look at this online. Let me see if we can find a gut pick of this amplifier for 13 BTR, because I want to give some valuable information. You know, you donated like $20 freaking. Okay, right. Now this can be deceiving because this sort of board layout has been cloned. There's similar ones of these being made like in China that look lovely but aren't necessarily that good. But Stereo Integrity is a pretty nice brand. I don't know do they design their own circuits or do they just buy them from a build house? Let's have a look. A blend of Hi-Fi Class AB and D. Eh? Also, is it a 5-channel or something that's got a Class D sub-channel? Doesn't look like it. Oh no, here we go. Okay, right, this is just telling you about all the amps in the line. Okay, so the 75.4. So it's using these massive TO3. I think that is. Is that TO3? Package output transistors. Wow. And then, are they the drivers maybe? Freaking 247 AC drivers? Wow. I mean, like, just looking at the guts, the layout is really nice. I don't like upright daughter boards, especially not in car audio though. Just from a reliability standpoint with vibrations and stuff, it's unnecessary. I guess they were trying to pack everything in there, but so it's going to be very hard to comment on like how nice these are going to sound, because you can't tell that by looking at the guts. The parts look like relatively decent. The board could be alright, but it also could be like one of these really cheap, like the orange PCBs from China are like really thin and kind of shit. Yeah, the Railcap brand is like pretty much no name. I think. Like, I'm not a connoisseur of Railcap brands, but I don't recognise the name at all. They certainly look really nice, but the only way you can tell for real would be to get one on a signal analyzer, check out the THD, check out the channel separation, check out the floor noise. But they look pretty nice. But they do look suspiciously like something relatively cheaply made in China, but that looks flashy to make you think it's expensive. So yeah, I don't really know if Stereo Integrity designed their own circuits. I've got a funny feeling this is just something kind of. It might be fine, it might be really nice, but I don't think that it's a bespoke circuit design from them. I could be wrong. We've got some frequency response graphs and stuff by the looks of it. What's this? Can I just open this in a bigger bloody picture, please? There we go. Hello, can I have your contact? Ayush, just message me on Facebook, buddy. Bearvids Facebook page. Facebook.com/Bearvids. Send me a message. What have we got here? Sorry, we're looking at audio precision. dBr hertz. What are we supposed to be looking at here? Oh, EQ. Oh, okay, so this is how flat it is, basically. And they've gone all the way up to, what's this? Freaking 200 kilohertz. Okay. So you could give a demo to your bat friend. Okay, so it's obviously flat, that's fine. Wouldn't expect it to not be. What's this one? THD. So they've done their tests on it, so it looks like it will be pretty nice. Like, if it was terrible, they wouldn't really be kind of showing you this stuff. Yeah, it's going to sound pretty nice. That's all the different amplifiers, THDs. Yeah, so I mean, provided it's not stupidly expensive. The thing is, right, in an automotive environment, yeah, in a car, it's not the ideal listening environment. Okay, you got road noise, you got engine noise, you got loads of reflections in the cabin to deal with. It's a really small space. You're not sitting in the middle of the two speakers, so you got like delays that you got to add and stuff like that. So it's a really poor acoustic environment. And with all of the other noises going on and stuff while you're driving, you're not going to pick up on like tiny differences in THD percentage between one amp and another. So really, you want an amplifier ideally that's got a nice low floor noise, so that when your park's up and your engine's off, you're not got coming through the speakers when there's no music playing, ruining your dynamics. You want decent channel separation, so that you could, especially in the small space like that, so that you haven't got like audio leaking from one channel going into another speaker, which is like causing your stereo image to be less focused. So good channel separation, low floor noise. The THD, as long as it's like under, you know, a normal amount of, like, you know, as long as it's not like super high, you're not really going to notice it, especially with the kind of drivers most people use in their cars. And also you're sitting off axis to the drivers a lot of the time, unless you've got like drivers on the pillars that are facing you that are doing all the high stuff. So really don't worry too much about it. Just get something that isn't going to absolutely rinse you dry in your wallet, and that's built reliably from a good brand, and buy used amplifiers as well. I'm a big connoisseur of buying used amplifiers, he says, as he has to take the back off this one to fix broken traces, but this is very old. I wouldn't buy something this old, but Big D did a dyno and they made overrated power. Hopefully it sounds good as well. By the looks of it, it's going to sound fine. It's going to sound more than good enough for a car audio setup. So yeah, provided they're not stupidly expensive versus something like an Alpine V12 or something that's like a really nice amplifier, then yeah, jump on it, go for it. Probably be really nice. Amplified noise has been a non-issue for like 20 years now, unless you've got a really crappy amp or wiring issue. Yeah, pretty much. That looked like an SI amp in the thumbnail. Oh wait, what's the thumbnail for this live stream? I can't even remember what the thumbnail for this live stream is actually. What is it? I think it was like an in phase in the thumbnail for this. The thumbnail's been the same for like the last 3 streams, so apologies. The thumbnail doesn't actually mean anything for today's stream. I'll just keep forgetting to change it. I'm going to plug this back in and we're going to see whether reflowing all of those joints has made any difference. Pop that back down there. And yeah, we're going to go in with channels A, left and right, as I want to make sure that they're still working the same. We haven't disturbed anything. Line in A, and then let's flick the switch on the side to input selector A only. Stereo, low pass filter, high pass filter off, etc. Bit of power. Connect our remote wire again. Okay, now let's see. Okay. Okay, now so we still got an issue. So there definitely is a fault somewhere. I'm just gonna like tap the board around a little bit just to see whether like this waveform changes at all, which would like show me that there's like a broken trace or like a bad solder joint somewhere. No. Okie doke. Right, let's start probing some actual components then, because we definitely have what appears to be a component issue. Now I do have a recollection at one point that this issue may be caused by an open emitter resistor. I have a vague recollection in the back of my mind somewhere that I had a similar issue with an amp like this a while ago, and the problem was an open emitter resistor. So I'm just going to check all the emitter resistors. Yep. 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 Wait a second, would you look at that? What do we have here? Da, 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 da. That resistor is open. And that's a 0.1 ohm. Fucking hell, that memory seeping in. Right, well, let's change that and that probably fixes it then. So I need a 0.1 ohm. What have I got? There we go, there's 0.1. This is a little bit big. It's a bit chunky, but it'll work. Now I did actually Google a while ago. I was umming and ahhing. I was like, for emitter resistors, surely you don't want a wire wound resistor because that has some inductance, and you don't want an inductor in series with your speaker because that's going to act like a bit of a low pass filter, depending on the value. But I realised that it's basically a non-issue because the inductance of a wire wound resistor will be like negligible, and the low pass filtering effect that it'll have will be like in the ridiculously way above audio frequencies. So it's a bit of a non-issue. So this is 0.1 as well, R10. I think that's a bit more sensibly sized compared to the one that's in here. Yeah, I think we'll roll with this one. Yeah. So that is right here. Okay. I'm not gonna lie, it feels quite good to have called it like that. Yay, a real amp for a change. Man, this is nothing special these days, man. This was good at the time, but people have rose-tinted glasses for old stuff. Dennis says, hi Sam, Def Bonts 1800.2. Each channel switching has a little different switching frequency, 380 versus 430. That's perfectly normal. These amplifiers are very unoptimized circuit layout, and that issue actually comes from a board layout issue. So if I'm remembering rightly, one of the channels is significantly further away from the drive circuit than the other, so the gate traces are much longer. And that causes the variance, because it's a self-oscillating circuit, that causes the variance in switching frequency. You can actually get them closer to each other by changing the gate resistor value. So you have like, I can't remember if it's slightly higher or lower, I think it might be slightly lower value gate resistors on the channel that's further away, and it brings the frequency more in line with the other channel. So if you do care about it and you want the frequencies to be similar, maybe drop the gate resistors a bit on the channel that's further away. But honestly, it's not an issue at all. You don't need to worry about it. You can just leave them as slightly different, because it's a very, very poorly optimized, poorly designed circuit anyway. So, and they're kind of noisy. They're not designed to be like, oh yeah, super nice sounding, like whatever, blah blah. They're designed to just be stupidly loud, like, you know, for like big PA builds and shit. So don't worry about it or overthink it too much. My ice power amps use a different switching frequency. If it's in the specs, I wouldn't worry about it. Yes, actually, some amplifiers will use ever so slightly different. It won't be as different as like 380 to 430. But some amplifiers will use slightly different switching frequencies on purpose to prevent kind of like ringing or whatever. to keep it, if you've got a multi-channel amplifier, having the channels be ever so slightly different switching frequencies prevents the kind of noise overlapping, and I can't think of any words to describe what I mean. But yes, basically sometimes it's designed that way for a good reason. Right, I'm just dropping a bit of fresh thermal paste onto the heatsink here. For the average person without a scope, would they be able to tell that this amplifier had a fault just by listening to it? Yes, if you were listening to it properly. That channel that had that weird shaped sine wave, basically the reason that it looked like that is because one of the emitter resistors was open, so basically only the top half of the sine wave was being recreated. So it would have sounded absolutely horrendously distorted and very bad to anyone listening to it that was actually listening to it properly. So yes, if the seller would have tested this properly on all 4 channels, they would have known. However, the reason that the seller didn't know about this was because this amplifier, although it's a 4-channel, was being used with a subwoofer. The guy planned to use this amplifier on a freaking Pioneer 212 SPL. Anyway, so basically only the A side channels have grub screws in the terminals, so the B side channels were just being completely ignored and wouldn't have ever been tested or checked anyway, because he was just bridging between the A side channels. So yeah, it's just one of them things, isn't it? But I mean, how are you going to test that if you're buying this on Facebook Marketplace? What are you going to do? Go to the seller's house with a little power supply and an oscilloscope and check all the channels? Like, no, it's one of them things. Oh, Mello, you got that song in my head now. Why'd you do that? Oh, think twice. It's just another day for you and me in paradise. I'm screwing this back in, but I haven't actually confirmed that it's fixed now. But we know it's fixed, guys. We know it's fine now. Actually, maybe I should just check that that transistor's not shorted. I'm sure it's not. I'm sure it's just the gate resistor. Yeah, it's fine. Yeah, it's fine. Did I say gate resistor? I meant emitter resistor. Tonis says, we've all done it. 100 watt 4-channel wide up to a 1K woofer. You say that, but I never did that, but I guess that's because I had prior knowledge, because I did audio in the bedroom before going to a car, so I guess I got an excuse for never doing that. Some guy bought an AV receiver off me and insisted I set it up to prove it worked. I set it up in the hallway. Like, it's annoying, isn't it? Like, this sucks when you get a buyer that's like, oh yes, do you mind setting it up and plugging it in and check it works and check up some speed? Do you mind if I bring a multimeter, unscrew it from the box and take the top off and just have a look? Like, it's annoying, right? It's like, oh fuck's sake, you know it works. Like, if you're a seller that you know your stuff, you know it works. But the guy who's buying it doesn't know that you know your stuff and doesn't know that you know it works. So it's annoying, but you gotta understand it, because if you were buying something and if you were like laying out a decent investment in something, then you want to make sure it works as well. And if you're in the know and you got the test equipment and you know what quick tests to do to make sure it works before you part with your money, then you got to kind of just understand it, I guess. Did the Canon camera make it? Yeah, Kevin, thanks for asking. For some reason, yeah, I just plugged it into a battery instead of the main supply, and yeah, it worked fine. So I have no idea what it was unhappy about, but it looked pretty serious, because it wasn't even going through its like power up sequence. It was just flashing error 70 like instantly. So I was like, shit, I was like, fuck, what's going on? But nah, disconnected the battery, new SD card, and it's sorted itself out. I have an old DDZ one with some bulging caps and think about replacing them. Are you sure that it has bulging caps? Because a lot of the times the plastic top to the capacitor is domed and it makes it look like this bulging capacitor, but actually it's not. So if you push down on the capacitor and it's like springy, then it's not actually a bulging cap and it's fine. So just double check that first, because it might not actually be a bulging cap. You only wanted 30 quid for it. Yeah, but still, someone's parting with 30 quid, aren't they? So you got to understand it, I guess. We've seen those giant 100,000 amplifiers from Indonesia for DJ use. They have like thousands of effects in them. I don't think I have. I think the biggest thing I've seen was like a power soft, like 20k or something like that. But that's pretty crazy. I imagine that those kind of 1,000 watt amplifiers, 10,000 watt amplifiers will be, they won't have like a power supply section. They'll be rectifying the mains voltage directly, and it'll just be like hundreds of paralleled IGBTs. Yeah, it's not just the rail caps, it's other caps around the board. So the power supply section FETs, yeah, they do tend to, you do tend to find power supply section FETs that get bulgy. So yeah, you can just replace them with like whatever. I mean, I say that like they're not critical to the audio side, the power supply FETs. Sorry, the power supply capacitors. They're just there to filter the power supply switching noise coming back down into the vehicle, and you don't need anything really crazy for that. So just like, you know, Panasonic capacitors or something would be fine, relatively okay priced and pretty available. There's only so much power you can pull out of a typical circuit. I don't know. It's not really. Like, if you just keep paralleling stuff, then you just get more and more, don't you? Like thicker traces, thicker PCBs, or like straight big ass 70mm wires instead of traces. Like you think about high-speed trains, okay? Or think about like what's that in China? They've done a maglev train now that travels at something stupid like 400, 500 mile an hour, and they're trying to get it up to 800 mile an hour or something like that. You think of the kind of IGBT circuits that will be driving like the electromagnets in that, or the accelerator kind of coils in that, or even just, you know, your regular kind of high-speed trains. What kind of IGBT drivers are driving the motors in those that have thousands of brake horsepower? Like, you know, it's monstrous. I mean, your Tesla, your fastest Tesla vehicles, you know, they're accelerating with like, you know, 1,200 horsepower, which equates to over 100,000 watts. So you're going to have, you know, motor controllers that are doing that, that are passing that much power. So, you know, it's we are there with power for sure. Oh, sorry, you mean mains. You mean main circuit. Well, if you've got three-phase, you know, like, you have big power going into factories and stuff, don't you, for like hundreds of thousands of watts. And you've got big power going into, you know, the train line supplies and stuff like that. So there are hundreds of thousands of watts available for you if you have the infrastructure to support it. So, there's one where there was a diesel generator running it, and whenever you hit a long low note, you can see the diesel Jenny get loaded and it starts fucking going for it. That's hilarious. I want to see that. Just a question, because I can't find any info. I have a Pioneer 8604. has a constant hiss without the RCA connected. I've tested the ground. Yeah, that's unfortunately, Jack, that is just a byproduct of that amplifier, unless it just has suddenly started. That is ground noise. That's floor noise, not ground noise. Sorry, that's called floor noise, and you can check that in the amplifier specifications, signal to noise ratio, and that's just a byproduct of the amplifier you've got. That's just how it works. It's probably a Class D 4-channel, and Class D is noisy. You do get hissing unless it's been really well designed. The only Class D full range amplifiers I've come across that have like barely any audible noise is like Alpine. They're amazing with their full range Class Ds. So yeah, unfortunately it's just a relatively affordable full range Class D, and you're going to get floor noise with it. So if you don't want floor noise, you need to get a Class AB or a better designed Class D. Have you seen Loudfear? Yeah, man, I'm a good friend with Marius Loudfear. I haven't looked it up yet. I've not got a camera facing this way. I've got one of his high precision voltmeters here on the workbench that I need to hook up and get a camera pointing at some point. I just haven't got around to it yet. Okay, are all the screws back in for the main board? Yeah, looks like it. I just need the preamp board going in now. Come on, get in there. Now, this is like the jankiest way of connecting the main board to the daughter board. There we go. That's one. Yeah, most JL amplifiers are pretty well engineered, I agree. Sometimes a little bit over-engineered. They're sometimes a bit unnecessarily overly complicated, and they have like a lot of failure points as a result of that. Like the more complicated you make something, the more chances are that something's going to fail in there. So there's a balance between a good design and keeping it as simple as possible. And honestly, that's where Taramps have nailed it, in the bass amplifier market at least. Taramps amplifiers are beautifully simple, but perfectly optimized. They're wicked little things. Man, I wish he was in Texas. I don't. Sorry, no cap. I have a Kenwood. I believe it would blink the power light 3 times and then turn off. We wanted to keep it, but I sent it back and got 2 Fosgates. Ah, shame. Well, at least you were able to send it back. At least you didn't like lose out on it. Okay, we've got 1 screw left. Where does this go? Nope, 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 nope. Why does this always happen? Why are you always left with 1 bloody screw? Nope, everything is screwed up. I don't see anywhere where I've missed one. Weird. Maybe it was on the top. How many screws have I got for the top? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I've definitely missed a screw somewhere then. Where? Well, I don't see it. It's fine. It's fine. Okay, let's power it up then and just make sure that that emitter resistor was the only problem with this. I'm sure it was. the only issue. Let's just go for a cheeky power up, put some RCAs back in. Should Class AB have continuity between the speaker outputs? The negative terminals, yes, not the positives. If any of your... I have to be careful here. So, with a Class AB amplifier, most of the time, the right channels will be flipped inverted with the plus and minus. So the one that says positive is actually a ground and the negative is an inverted positive. So with a Class AB 4-channel amplifier, 4 of your terminals should have continuity to each other. It doesn't matter what they're marked as, but it'll be 2 of the negatives and probably 2 of the positives will all have continuity to each other. The other ones, or any terminal that's marked as a bridge terminal, so any terminal that you would use in bridge mode, should not have continuity to any other terminal. That's easy way of putting it. Okay, let's go. Power up. 12 volts, go down to like 9, there we go. Powered up, and we have, okay, that's better. Oh, that's annoying. Right, okay, so we fixed the problem with the uneven clip, but we still have an issue where we have less signal. We have uneven, like, signal on one channel versus the other. One of them is much louder than the other. That's so annoying, man. Now that's got to be a preamp fault. Right. Let's turn our attention to the preamp here. So we've got sine wave there, sine wave there, sine wave there, sine wave there. So we should have 4 sine waves. We should have 2 coming out from the preamp board and 2 probably coming from the main board as feedback. So on this side we have sine wave, sine wave, sine wave, sine wave. Yeah, I think it's an issue on the preamp board itself. Okay, I guess we're just going to be following the signal through then and seeing where one of them is louder than the other. So annoying. The feedback one should be 180 degrees out of phase, eh? I can check that with the old double probe. Let's grab the old double probe and let's check that. So we have, are these the one? They're in phase. No. Okay. So that's in phase with itself. No, they're supposed to be, well, they're in phase. On the working side and the non-working side. On the one that's like too loud and the one that's not too loud, they're in phase with each other. But that was a good thing to check. That was a good test to do, just to see whether that was different. That is not preamp. All the sine waves are the same height. They're not the same height. So I currently have both channels going in here, right? So I have this channel, which is too high, this channel, which is too low, okay? Now if we have a look at the outputs from the preamp, we have this side here, which is too high, and this side, which is too low. So that's coming from the preamp board, yeah? So the issue is on the preamp. So I need to just follow the signal through and determine where it's, like, I don't know, where there's an issue, I guess. Let's just see whether any of these switches here affects the signal level. So we have stereo, left, right, or mono on this switch. Okay, stereo, left plus right. Let me unplug one of the RCAs and let's just go for mono And let's see whether the issue is still the same. So if we mono it, yeah, so we still have a difference in the output level with it monoed. Mono left right plus, we still have an issue. Okay, so it's like towards the end of the preamp circuit, I would say that there's going to be an issue here. Let me try wiggling the gain potentiometer. So with the gain on minimum, we have 1.4 volts RMS on this channel and 0.5 volts. With the gain up super high, we have basically the same difference between each channel. Okay, so the gain potentiometer is probably not the issue here either. Let's have a twiddle with the high pass low pass filter switch. Okay, well that's working as intended. Let's increase the frequency, let's decrease the frequency a little bit and turn up the low pass filter knob so we get more signal here. Yep, that's working as intended. Okay. Weird. A tempting test to do actually is to swap round which channel goes from the preamp board to the main board. Do you see what I'm saying? So obviously we've got these headers here that go from the preamp board to the main board. Now if I switch round which channel is going where, then we should see whether the problem's on the main board or whether it's on the daughter board, the preamp board here. Another test I can do is actually just to disconnect the wires going into these headers here. And by disconnecting them, I can then just have the output from the preamp without any stuff coming from the main board influencing it. Okay, let's power that off. And just before we go any further, I am going to reflow the connections from the headers on the top of this board. Yeah, the soldering does look a bit different over by the RCA connectors. It looks like that's been resoldered at some point in the past, for sure. Maybe I'll just drop some solder and reflow that just to make sure that there's not an issue over there. But it looks like, honestly, it looks like that the issue here is either right at the start of the preamp circuit or right at the end. And what I want to do is follow the audio signal through the PCB and see where the level changes. Because what we can do is we can follow the audio signals from both channels through all the op amps and see at what point through the circuit do the levels get different. There we go. Is it easy to inject right there instead of swapping the wires around? Oh, yeah, you're right again, Dr. Dino. I should probably just inject some signal from my generator into the main board, and just to make sure that it's not an issue on the main board. Yeah, good shout on that one. We'll do that. I'll just reflow those. Just want to see if that made any difference at all. Okay, so same issue there. Right, I'm just curious. Let's just kind of follow through the preamp a little bit here and just see if we can see anything. So I'm going to turn the gain on the amplifier right down so I can turn the signal level right up so we can see it nice and clear on the scope. Right, there we go. So that's pretty much just before clipping on the output. So now we should be able to see that nice and clean through the preamp. Okay, so that's one channel there, 3.7 volts RMS, and There we go. So we've got the same amplitude on both channels there. So let's go after that resistor, 3.4. 3.4, yep. Through the DC blocking capacitor, 3.4. 3.4, that's correct. And then that goes to ground. And then let's follow this one through over here. 3.4, 3.4. Okay, let's do the same for the other one. And that goes all the way over here. Just checking that. We've got some DC here actually. We've got negative 16 volts. Maybe that's a capacitor. 3.4, 3.4. Does that have continuity on those two? Just out of interest. Yeah, okay. So we go over here, we have 16 volts on one side, audio signal on the other, through there, and then we're still at 3.4 volts. We get 6.8 after that resistor, and then here we looks like we have an op-amp of some kind. Okay, let's do the same on the other channel. So the other channel we came in, went blah 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 through there, that one, that's there, follow that through the DC blocking capacitor, and let's jump over here. We're at 3.4, that's where we're supposed to be. Then we go all the way over here, 3.4. Okay, let's just unscrew this so we can take a look at the top of the board. Where you're getting your scope ground. So the scope ground is connected directly to the power supply negative. So the ground path is quite long, which means that you get a bit of noise on the scope when you're looking at small signals, but I don't really care about that because I know that it's there. But if I needed to do any super critical, like very, very small signal scoping, then I would connect up a direct ground connection to a nearby ground reference of the circuit that I was working on. But I don't need to do that because most of the stuff I'm working with is high sort of signal stuff. Now we've got this underneath this little metal thing. There is an op-amp by the looks of it. It's annoying that I can't get to that from the top of the board without desoldering something. But whatever. Let's just have a look through that. So that's an op-amp under there, isn't it? And that's like shielded from the. That's shielding for the power supply transformer, so it doesn't introduce noise into the preamp circuit there by the looks of it. So let's just have a look. Just make sure that the signals for both channels are the same on this op amp. So 6.8. So they're actually a little bit different over here, but that might just because that's the output. So the output of that one, 6.8, 6.9, and then this one's super low. Okay, 3.0, 3.4. I think the difference is happening over here, guys. 3.0, 3.4, 3.0, 3.4. I think the difference is happening over here at this op amp. Right, let me find that exact circuit, but on channels, on the A set of channels, which are working fine. Now that identical circuit should be over here, by the looks of it. So I'm going to now swap the RCAs round to the channel that doesn't have the difference in signal level. I'm just going to check what we have over on that channel, because we have a working version of the circuit that we're investigating here, and that's really handy. That's going to be just a clone of that circuit, isn't it, over here. So I'm going to turn the gain down because we've got the input sensitivity cranked up pretty high here. Okay, there's a big ass sine wave. There we go. So if we follow it through now on the A channels, There we go, through there, through the DC block. Over here, and we have 3.3, that's about the same. Over here to the op amp. Okay, so on this op amp over this side, we have 3.3, 2.9. Okay, so there is still a difference on this op amp. Okay. But these should be the same. Left and right, they should be the same. Okay, so that's actually intentional. We're supposed to have different amplitudes of sine wave on either side of this op amp. Let's just remove one of the RCAs and check the channel. So that's that channel, and that's that channel. Okay. Right, so they should be equal and they should be equal, which they are. Fantastic. Let's move our way back over to the B side, which is the one that we're investigating that's got a problem. So we have 6.7, 6.7, 1.3, 1.2? Is there a slight difference over there? Maybe. No, this is the same. Right, so there's no issue then over here at this op amp. Great. So now we need to move on and find out where it goes after that. So obviously it goes into some of these switches here. So what we can do is find the next op amp along that it uses. So let's go, for example, I know this one here. So we've got audio on this op amp here. Let's just check this one. We've also got audio on this op amp, but not coming out of that side. Okay. Yep. So we have 700. Ah, there's a difference here. Here there's a difference. I should probably just look up a schematic of the amp, shouldn't I, at this point? That would probably help me a bit. So that one's the other channel, that's fine. We have nothing here, okay. So we actually do have a bit of variance here. We've got 0.7 volts there and 1 volt there. So there's a difference. We've got all 4 there. So let me just go over and put it back in the A channel. Let's check this one. 1 volt there. 1 volt. 0.7, 0.7. 0.7, 0.8, 1 volt, 1.1. Okay, there is a tiny difference I'm seeing over here. .0 and 1.1 over here. Now on the other channel, that's both exactly the same voltage, but it's slightly different over this side. Okay, let's go further along. Let's have a peek at the circuit a little bit further along. We have a bunch of discrete transistors and a couple of big ass resistors here. These are probably going to be stepping down the for the auxiliary supply. A 0.9 volt RMS sine wave there, and a 1.1 volt RMS sine wave there. Okay, that comes from here, which then comes from here, 1.1, and this one here Comes from here, from this op amp, this 072. Might see if I can grab a schematic for this one, just because I think it will make it quicker to follow the signal through here and find something that's like leaking or out of tolerance. Because with preamps like this, it's kind of difficult because the signal kind of split off into all different ways. Alright, what I'm going to do is I'm going to disconnect the little pieces of wire that have the sine wave on them, so that I can determine which ones come out of the preamp board and which ones are coming from the main board. And then I can inject some signal into the one that goes to the main board. So we've got these two here. These ones 3 and 4 up from the bottom, and 3 and 4 up from the bottom on this one. Okay, so let's turn that off. Disconnect these here. So I'm going to bend the little pieces of wire here so that they don't go into the headers. Number 3 and 4. And that way we're just going to see what's coming from the preamp, and then we'll know which one comes from the preamp and which one comes from the main board, and we can inject our own signals. And the same on this side. Three and 4 up from the bottom. Right, so that's now disconnected, so there's no signal going from the preamp board to the main board now. Which should mean that we can identify if the issue is coming from the preamp board or if it's like a feedback issue from the main board. Let's power up, turn the signal down a little bit. Okay, so we have, without that there, we have like loads of DC, I think, on the amplifier because there's no feedback. Is that right? That's annoying. It doesn't look like I can keep the amplifier powered up. No, just get negative DC there. That's interesting. And one of these just has like a massive swing to negative 28, swing to negative rail on it when those wires are disconnected. That's interesting, and the other one doesn't. That might be part of the issue here. Why would that have negative 28 volts on it? So 3 and 4 up from the bottom. That's coming from the preamp board. And that's this transistor here. I wonder whether that transistor is shorted. Yeah. You know what, guys? I'm wondering. Let me just check some of the transistors on this preamp card up here. I reckon one of these might be on its way out or something. maybe that's what the issue is. So we have 641. Okay, that's reading all right. That's looks like it's maybe reading all right. My multimeter camera is glitching as usual, even though I've put a new USB connector on the end. It's really strange. It's definitely just 3 and 4. Up from the bottom for each of those. They had a sine wave on them, but one of them now has like straight DC. Not that one. Wait, now it doesn't. Oh man, I'm so confused right now. That was swinging to negative rail a second ago. Oh, that one is now. I'm sure it was the one down here that was doing it before. This is mad confusing. Well, that's definitely doing it. That one's not. That one now is. I guess without being connected to the other board, they kind of like, they don't do what they're supposed to do. And the amp just kind of goes into protect, so I can't really like follow the audio through anymore. I don't get any sine waves or anything where I was previously. I get some at the op amps though, which is good. So if I turn that back up, I can at least check it at the op amps here. I'm finding a difference in signal here at this op amp. We've got, on this channel we've got 0.7 volts, and on this side we've got 0.65. It's like a very minor difference. We've got 0.5 volts of signal there. And then this one we've got, again, 0.5, so that's equal there at that point. What's going on, Donnell? Hope you're well. Like guys, you know what it is? I actually think that this part of the circuit up here is not just preamp. I think that part of the circuit on this daughter board is actually the drive circuit for the channels, like part of the Class AV drive circuit. So I think that the preamp circuit ends like around here, and then this actually becomes part of the Class AV drive circuit. So I don't think I'll be able to inject any signal at those points. But given that the channel that has too high of a signal was the one that had the open emitter resistor, I'm tempted just to go ahead and like start checking some other components around this channel, because if that was open, then maybe something else is kind of like dodgy around that area as well. So I'm just going to check some of these smaller resistors. You've got this resistor here, R129, 5.5, 5.6, 5.6. What's this big one here? What's this big boy doing? That should be what, 100 ohm? That looks like it's been replaced before actually. 100, yeah. 100. Yeah, that's been replaced before. This amp's been worked on before, guys. Interesting. 3K there with the red. 3K there. Now hold on just a minute. 17. That's correct there, based on that one. 609, 610. Yep. 100 ohms there. 100 ohms there. I'm just checking all of these diodes, making sure that they all read correctly and they're not like low resistance one way around, not the other, for example. It's kind of frustrating, not gonna lie, guys. I can't really look at the signal going in to each channel, but just because of how it's like laid out. Low resistor values correct, 10 ohms and 10 ohms there. Obviously we should have like a set of 4 up here. This is a 4-channel amplifier, so we should have like 4 equal drive circuits, 4 things we can compare between up here. 18K, 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 18K. Maybe if what I do is if I put it on 4-channel mode so that we've got the same signal going into all 4 channels, then what I'll be able to do is find the one that is different. If anyone's wondering, this super isn't worth it, by the way. This amount of time on this repair is super not worth it, but I'm kind of invested now. And this is my own amplifier anyway, so I don't really care. So guys, I want everyone to give Sinewave02 in the live chat right here. Send him best wishes for a very happy birthday. Happy birthday, my man. Hope your day's been going well so far. Right, so we're putting it onto 4-channel mode now. And we're looking for the one that's different. We're looking for equal, kind of identical circuits, and we're looking for the one that's different. Okay. Okay, now this is really good for us to see. So the issue actually appears to be the channel that is too quiet, right? So on all 4-channel mode, we've got the 2 channels which are working fine, the top 2 channels. We have 16.8 volts sine wave, 16.8, about the same there. 17 is a little bit different, but it's fine. Then we have 18 volts down here, and the one that's incorrect is the one that's only at 6 volts. So that's the one that we need to be looking at. It's the one that's too low that's the issue, not the one that's too high. Now I'm just going to pull this off for a sec, and I just want to double check, is that the channel that had the open emitter resistor that's too low? It's not. Okay. The channel that's too low is, in fact, this one over here. Okay. So let's just check the emitter resistors down here. I mean, I'm sure that won't make any difference. The emitter resistor being a different value wouldn't change that, but 0.1. So I probably think that stuff down here is fine. I think it's going to be on the preamp board up here. So now, on the preamp board, we power up and we compare between the 4 channels. We find the one that's low and we chase it back. Right, so we've got 16.6, yeah, so this is the Class D drive circuit. So, not Class D, Class AB drive circuit is on the daughter board here. Right, that's the one there that's low. That one's alright, that one's alright, that one's alright. Right, so we're over here. So we're looking at these 2 here that are going all the way back to over here. Which only has a 6.4 volts RMS waveform on it, whereas it should have a 16 volt RMS waveform on it. Right. So our issue is this little set here. So I guess what we do is we just probe each of these transistors and we just look for differences. Right, so over here we have, if we zoom in on the scope, we have a little bit of DC, and we have that riding just above the first threshold, so we have just, yeah, 0.7. Okay, so we need to find the same thing on one of the other channels and compare that. So that's going to be okay. Well, there's a potential thing there. Right, that's the output. That's the output. That's nothing. That's nothing. Then over here we have low signal. So the wave that we should be getting is this 1.1 volt, whereas on the bad side we only get 0.7 volts. Okay, so that's coming in from here. Bit of DC on there, that's no good. Right, that's some signal from that transistor. 0.4 volts on there. Let's check down here, we have 0.9 volts, so that's wrong again there. So if we follow that, that's a bit of feedback. Right, I wonder whether one of these resistors is bad. We have 0.3 volts. That one's 0.9. .0, 1.3 coming into this resistor. .2, and should have another one coming in somewhere from the main bit up here. 1.2. Okay, so all of the channels which are the correct amplitude have coming into them from the preamp board. We've got 1.2 volts, 1.3 volts, and then 1.1 volts, 1.1 volt. Right, actually, you know what? It looks like we have equal voltage coming in from each of the preamp outputs, pretty much, like within a tolerance. I'm just kind of looking at traces coming from the preamp over here, going to the kind of output drive section. Okay, yeah, they're all equal. So they get unequal in the drive circuit. So that's where we need to turn our attention to. There's going to be a difference or an issue in this drive circuit right here. So let's follow it through. So we have 1.1-ish there. It's a little bit different, 1.1 versus 1.2, but it's not that much different, okay? If we go after the resistor, we drop down to 0.3. So the first resistor that we go through drops it down. That's where the issue is. Right, let's check the resistance there of the first resistor in line with the preamp going into the drive circuit. If the values are the same, then it's not going to be the resistor that's the issue, but it's going to be something that's like drawing current from that pathway there. So if we check from here, we go through this jumper, which is probably a jumper, yep. Then we go into this resistor here, and that resistor value is 4.6 up on this channel. Okay, let's compare it over here. That's a jumper by the looks of things. 4.6 again on this channel. So that's these two. We have And then let's check this one. That's probably going to settle at 4.6. Actually doesn't. Okay, this one's a bit different. Oh no, I'm reading the wrong resistor. There you go, 4.6. So we have 4.6 on all these channels, and this one down here. So let's check it on this one. Huh. What's interesting is I'm not really getting the same readings at all on this one. Getting stuff all over the place. 2.2, 2.2. Yeah, I'm getting super different readings on this one that's bad. Now the amplifier's off actually, but that's because I've still got the RCA plugged in. If I remove the RCAs, that should help. Let's test that again with the RCAs removed now. So 2.0, 2.1-ish, yep. 4.4, 4.4. It's definitely different. 4.45, there's definitely something different about that. And then this right here, is that a capacitor? Yep, that's a capacitor. Right, okay, let's check those resistors on the other side of the board here. I might actually lift the resistor out of the board, just desolder one side of it, just so I can read it correctly without it being in circuit. It's kind of interesting one, this guy, isn't it? I don't know who's following along or not, but this is kind of interesting. So we've got, just to confirm with you guys, we've got signal coming from the preamp board. We've got, this is our bad channel right here. So it's coming in, and this is the resistor that we're dropping voltage across that we shouldn't be. So we're dropping voltage across this resistor, whereas we shouldn't be dropping as much as we are. A good channel comes from here and goes round there up to here. This is the same resistor. So I'm reading, getting different readings between a good channel and a bad channel here. So I'm going to go ahead and just desolder one leg of each of these resistors, just so I can measure them like out of circuit. Right, there we go. So they're no longer in circuit anymore. Let's just give their legs a wiggle just to confirm. Yep, not in circuit, not in circuit. So I want to measure the resistance, please, of U, 4.6. And you're also a 4.6. Okay, so the resistor itself is fine. The fact that we're dropping voltage across that resistor more than we should be means that something is kind of pulling on the signal too much after the resistor. It could be any one of these transistors, I suppose. So what we're going to do next is solder the resistor. Actually, let's leave the resistor out. Let's just compare some multimeter readings between these two channels. So we've got the signal then firstly goes into this transistor. So I'm just going to read this one here. 1429 on this one here. And this one here, we have, nothing. That's interesting. 1426. Okay, I think we may have found our faulty transistor. Because we have very different readings there. That's this bad boy right here. This is a C945. Right, let's get you out of there. Let's drop you in the transistor tester, because I don't think you are okay. What are we thinking then, guys? Are you suspicious of that after seeing those readings? Ta-da! There's your problem. That is not a transistor. That is just a bunch of resistors. Fuck you. Fuck you, bastard transistor. Right, oh shit, what is that? What do we need to replace that with? That's C945. So I have no idea if that's like model critical for this amplifier or not. I could probably find one of these on a donor board somewhere. Well, yeah, that will definitely be causing the issue. Excellent. So I'm going to solder that resistor back in, and then I guess we're going to go hunt for a replacement one of those or similar compatible transistor from a donor board maybe. Well, let's just have a look at what the specs are of it first. Let's just Google the specs of that. What is it? 2SC, I assume. 2SC945. Designed for use in driver stage of AF amplified low speed switching. So this is 50 volt part with 100 milliamp collector current. I could swap it from another channel, but I know that this is the issue, so there's no point swapping it from another channel unless there's maybe more issues further down the line. But I need like some replacement of it, you know, so I'm just seeing what I can use to replace it with. Okay, let's just have a look and see what other transistors. So I'm looking for a 50 volt kind of drive transistory type thing. So let's see what I've got in my drawer here that's full of old drivers. See if we've got something that's kind of compatible. So I'm just curious, I can't remember what any of these are. MPSA 92, is that, what voltages is that? I can't remember. Okay, that's super high voltage, that's like 200 volts. Oh, we're looking for an NPN, by the way, so that's no good. How about a JRC? No, it's not JRC. JCBC 546C. What's that? Amplifier, transistor. Okay, it's looking promising. Yep, that's looking pretty promising. And the one I've got here is the 546. which is 65 volts. It's a little bit higher on the voltage, but that's an NPN. That should actually do the job. Yep, 546, 65 volts and 80 volts. A little bit higher, but the collector current is again 100 milliamps. And it's designed for use in amplifiers, so that should be fine. The only issue we might have is that the different model transistor here causes there to be slight difference in like level between the rest of the channels that are using the 2SC parts, but worst case I could just drop the JCBC parts in all of the channels, but I do just want to drop this in here just to see whether that brings it closer to where it should be. Let's just check the current gain. So of the BC part, we have a typical current gain of BC 546, which is what we've got here, and that's the C variant. (546B), 546, 546B, 546. Where's the C variant on here? 548, no. 546B, 546. Between 110 and 450, I guess. Ah, whatever, I'm sure it's fine. Okay, so I'll just tack that in place, and before we do anything else, because we've been soldering, I'm just going to turn this whole thing upside down to get rid of any like loose solder that's floating around or anything like that. Right, so moment of truth then. Let's see whether that has made all of our channels be equal or thereabouts now. Just turn that down a bit. Let's turn that up a bit. Power supply on. And we have everything connected still. Yep. Okay. Remote wire. Power on. Okay, let's see. Oh, helps if I plug in the RCAs. Okay, so we have... Uh-oh. So... Right, so we have the correct level now, but the wave shape looks bad. Yeah? I wonder if that's just because that's a different type of transistor that I fitted. It's like soft clipping at the bottom. Bloody hell. Right, let's see whether that bad wave shape is in the preamp or whether it's in the afterwards. So it's probably going to be in the drive stage, isn't it? Let's be honest. If it's there, right. So clip. Yep, it's in the driver stage. So we might have more damage in the drive stage, to be honest. Let's zoom right in here. Yeah. So we got clean sine wave coming from the preamp side, and then bad shape after the resistor. So I don't know if it's because that transistor is like not happy here, or whether there's a further issue on the circuit. So what I'm going to do is turn it all off. I'm just going to compare with the multimeter some more readings between these two channels, just to see whether there might be another transistor that's like on its way out. You need to change the resistor values for that new transistor. It likely has a different bias point. That might be the case as well. But this is going to get fucking annoying and complicated, isn't it? 760. Right, 648. Oh, hang on a minute. Hang on a minute. I think I might have put it in backwards. Or I think maybe the pinout's different. Oh, the pinout's probably different, isn't it? I hadn't considered that. I bet that the pinout is different. Right, let's remove that. No, I didn't put it in backwards, but I bet the pinout's different to the original part. Let's just check the data sheets and have a look at the data sheets and see whether the pinout is different on the data sheet itself. So on the original part we have 1, 2, 3 ECB, and on this one we have 1, 2, 3 CBE. So it's different. Right. Right. Well, at least we know that's why it wasn't looking right. So we just need to bend these pins around a little bit, probably. So what do we need? We need 1, 2, 3 to be ECB. So we need E. So we need to put it in backwards and flip 1 and 2 around with each other. Right. So we need to put it in backwards and flip 1 and 2 by the looks of it. So that's our original transistor there. We need ECB. So by default this one, let's just confirm that on the transistor tester. So at the moment we have, so we need to flip it round backwards and swap 1 and 2. Let's just try that in the transistor tester just to make sure that we get it right, and the transistor tells us that we've got the right pin config before we solder it in. Okay, so if we go backwards now and with those two flipped, let's see. ECB. We now have ECB on the tester, and ECB is what we need on the original part. Okay, so that's now correct. Right. So if I flip this over, and I'm just going to bend these pins a little bit further away from their legs because they're a little bit close. Let's just go over there, and there, go there and there. Yep. Okay, they're not going to touch each other ever. So yeah, like I said, backwards and with the legs flipped. There we go. Solder that in. Hopefully me putting that in with the wrong pin config didn't kill anything else on the board. Right. A take two. Right, channel 1 we have, let's just go up to 16 volts RMS. Channel 2, 15.4, yeah, that's within the tolerance of the components. And then these other ones, yeah, 14.4 and 15.2. Yay! There we go, guys, we fixed it. Clipping evenly, and there is a little bit of variance between each of the channels, but that's just due to this being entirely discrete circuit, like slight tolerances between the resistors used and like the freaking drive transistors and all sorts of stuff like that. That's one of the reasons why I'm not a huge fan of like older amplifiers like this, because there will be a little bit of discrepancy between each channel. Actually, even I bet you the biggest reason for it is actually in the potentiometers. So obviously with a stereo potentiometer, it's two potentiometers just mechanically coupled, but the tracks might have slightly different resistances, especially with the age of these amplifiers as they've been turned back and forth like thousands of times over the years. So yeah, freaking wicked, awesome. Was not intending for this to be such a ball ache. This was supposed to be just something that I bought off Facebook Marketplace to sell on quickly after taking the bits I wanted from the deal. But there we go. At least maybe you guys learned something from that. Oh, I found also, by the way, where the missing screw was. The missing screw goes in the middle, just there. So let's pop that in. Happy with it. I might condense this live stream down into a shorter video, because I think that the troubleshooting steps I took with this amplifier might be useful to somebody learning about repair. Man, I need a drink after that one. Sheesh. But at least whoever buys this amplifier from me now, this was purchased in working condition, by the way. I just want to point out, Facebook Marketplace do be like that sometimes, because sometimes people don't really know how to test things properly. Like, you know, plug it in, green light, it makes a bit of sound, yeah, it's working. But no, this was in fact not working. It had an open emitter resistor on one channel, and the other channel had a blown transistor in the drive circuit. So in fact, this was not fully functional. But whoever does buy this from me can confidently know that all 4 channels are fully operational to within their factory tolerances of each other, and that it's going to be good to go. I redid the resistors, yeah, I resoldered them. As soon as I saw that they were the same value as each other, I resoldered them. You can skip back and check that if you like, but I did resolder them. Roaming around, thanks man, appreciate that. Happy birthday to to Donnell, if he's still watching. What a way to spend your birthday, watching a Bearvidge live stream. Awesome. It's a shame that its physical condition has like, you know, seen better days. But there you go. Excellent. Alright, it needs some new grubs in the terminal. I might have to buy some more. Don't think I've got any spares in here anymore. Got one. Put one in. I might have some spares on a donor board upstairs in the loft, to be fair. But yeah. List that up as I'm probably going to get like £20 for this. All that effort. Right, what can we move on to next then? Should we do something else? Should we have a chat? Should we do something else? I can do the JL audios that were donated to me and try and make a working amplifier out of all the spare parts I've got. How's the stream looking? We are up at 70 viewers. Not too bad for a daytime stream. Oh, Joseph Hammond says, did you ever get the parts for the Taramps? Yes, I did. I did get the parts for the Taramps, Joseph. I could do that one just now if I can remember where the bloody hell I put it. Right. Let's have a look and see if I can find the Taramps, what was it, DX something or other? 800X4. Right, what have I done with that then? Let's have a look, Joseph. I will find that for you and we'll have a look at that amplifier together. Just bear with me, I'm going to go over to the other side of the workshop now, so just bear with me. You'll still be able to hear me. Some people care about the outside Zac, unfortunately. I've got loads of those Kenwood amps in my cupboard. Well, half of them probably have like similar issues to that. Right, what do we have over here then? What is it, an 800 times 4, isn't it? Can I find it? I bet it will be buried somewhere under this mountain of crap. Right, this is a Gladen that I can't fix. That can go there. This is something else, a Blaupunkt that I couldn't fix for a while, but probably can now if I try. This is an Audison AP 8.9 bit that I probably could fix if I can get some parts from UT Source. This is another Audison Class AB that's got a bunch of weird issues with the auxiliary supply circuit that I couldn't find for a while. Let's pop that down somewhere here. Right, well here we go, hang on a minute, what's this? Joseph, I think this might be it. What's this? Export. I think this might be it, Joseph. Here we go. Yeah, there it is, right. So they did send me the parts for this, I just have to remember what I did with them. Where's the back? I have the board and the end plate, but what have I done with the back plate? It'll be around here somewhere. Yes, and this needed a new power supply drive IC, if I remember rightly, from a long time ago, I think. It looks like I've got one fitted there actually, weirdly. Yeah, alright, okay. So what did I do with that part? Let's have a look in my drawers. So it's a power supply driver that they sent me. Maybe it's in this drawer here, let's have a look. A6601. So I don't think it's that, because this part has 10 pins, so it's not that. What about this one? Oh, here we go. 5033. Is that what I need? Might be one of those. I might have to look back on that live stream, Joseph, and remind myself what the part was, because I did find out what the part was I needed, but I can't remember what it was. I think it was one of these. DY 1A3Y 2BYF, 3B. Yeah, maybe I should just fit one of these and see what happens. Joseph, can you remember what live stream it was that I was working on your Taramps? I could go back and have a look and see what it was that I needed. Maybe it was one of these. It was a while ago now, wasn't it? It was like last year. Pretty sure it was like over a year ago. MX says, "Sir, you're not wearing pants." That's very good, very good. Yeah, if anyone can find the live stream from a long time ago while I was working on this, then that would be great. In the meantime, I'm probably just going to fit one because I don't really think I have many other like 5-leg ICs like this that it would be, so I'm just going to fit it and see what happens. Joseph, I think you need to catch up on the stream. What you need to do, Joseph, is you need to change the playback speed to ×2, because I think you're a bit behind on the stream. So change playback speed to ×2, and then when it catches up to where the actual live is, it will go back to ×1 by itself. The reason this is taking a while is just because my hot air gun isn't like warmed up yet, so it's just taking its time to heat up a little bit. There we go. Right, let's put that to the side. A little bit more flux. This is a very, very small chip, this. It's nice to do it with the microscope, but I can't be bothered, so we're just going to do it without. Go. Yeah. Ring ring. It's an 0191 number. I don't answer those. Usually scam. If it's important, they'll leave a voicemail. If you ever get called from like a business number and you're like, psh, what's this going to be? If it's important, they'll leave a voicemail. Right, let's check those pins. Okay, that's soldered in, whatever it is. We'll see if it's the right part in a minute when we turn it on. Maybe I should have answered that and put it on speaker for you guys. It could have been quite funny. If it rings again, I'll answer it on stream. I'll turn into Kit Boga. I'll become a new streamer of that. Had a customer come to me with a dead TO220 MOSFET, and in my browsing was a 7805. The guy insisted that it looks right and was convinced it would work. Oh dear. Yeah, I've seen all sorts. I've seen like 064 ends in the output section, and like power supply MOSFETs in the rectifier location, all sorts. So yeah, Joseph, I honestly can't remember what the issue was with this amp. I think it had a blown power supply, didn't it? Yeah, because I've fitted new power supply FETs here. I definitely recognise those, that batch. That's the power supply drive IC. I don't think it had any dead outputs, did it? Oh, it did. It had dead IRF 530s. Damn, I don't remember anything about this repair. So it had some dead IRF 530s, and we replaced them just temporarily with IRF 640s, just to kind of get it up and running, to see if it would do Class D switching, or to see whether it needed a new 209-3M, which is in the middle here. So yeah, I need to remember that, to replace those 640s with some 530s, just for the higher current rating. But okay, let's put some power wires to it and just see whether the power supply works now then, shall we? And then we can see if the 2093 works. Darktron, long time no see. Good to see you, buddy. Hope you're doing alright. I'm okay. Oh, Joseph said he wired 2 channels to the same mid. Well, that'll do it. I'm hoping then, given that the failure mode was like a direct user error, there's not going to be any drive circuit fault with the output side, because I would love to not have to replace the 2093, because they're a bit of a pain in the arse to solder, and also they're quite expensive now as well. Okay, cool. Let's turn this on and see what happens. I'm going to start off with a nice low current. Oh man, this remote terminal just does not want to stay clipped on, does it? I'm going to start off with a super low current, just in case that chip is like connected to 12 volts, or like it doesn't, yeah, it fucks up straight away. Let's probe the power supply MOSFET drain over here. And we're looking for some pulses. 1 amp. I'm only letting 1 amp in right now. Oh, there we go. Yeah, we had some pulses. There we go. Fucking awesome. Yeah, so that was the correct part for the power supply. Excellent. Now let's turn our attention over to the output sections. We've got positive rail there. And low side there's nothing on it. Good. Okay, that's all looking promising. So I'm going to up the current now to about 4 amps, and we're going to look for low side switching on the back of this 640, and that will tell us whether the 2093 survived or not. Oh, nice! Yeah, there you go. Yeah, Class D switching on all 4 channels. So yeah, that's all it was. New output FETs, new power supply FETs, new power supply gate driver and gate resistors and VCC resistor. Excellent. So I do need to replace the 640s with the 530s though, because that's what this amplifier uses before it can go back in the case. And I also need to try and find the back case. I don't know what I did with that. The back plate. Hopefully it'll be around there somewhere. I could always make one for it. It doesn't screw into anything. Alright, so the reason the output switching looked kind of bad is firstly, because it's a very, very fast switching frequency on these amplifiers. Secondly, because my oscilloscope ground probe is nowhere to be seen. It's like my oscilloscope is grounded through my power supply negative. So it's always going to be a bit noisy with very fast frequencies like that. If I wanted it to be cleaner, then I would need to find a local ground reference and clamp it on. But I know that this is going to be noisy. If I need to critically look at any wave shape that's like a very low amplitude, then I will connect up a ground reference. So that, yeah. Anyway, yes, 530s. Do I have? Not much anything. Probably about 2 minutes. Okay, so I'm just going to have a very, very, very quick look for some 530s, but then I do need to shoot off to be somewhere. So, here we go. Here's a 530. That's a 530N. That's 1. 540. 540. 540. 540. 540. I can add some to my next Farnell order if I don't have another 530. 40. 540, 540, 540. No, I do need to purchase a couple new 530s. Yeah. Yeah guys, that was pretty fun, wasn't it? A little cheeky daytime stream. It was an unexpected difficult repair on the bloody Rockford, but I hope that was interesting, entertaining and educational for those of you that followed it. I am considering making that one be its own video because I think it's going to be interesting for people that are learning how to diagnose and stuff. So yeah, look out, that one will probably become a video and you can skip that one if you watched it already, obviously. But yeah, thanks for keeping me company today. Oh, didn't Taramps send you some? No, they only sent me the output, the power supply drive IC. I didn't ask for any output FETs, so. But yes. Yeah, cheers for keeping me company, guys. That was a fun stream. I will probably do another stream on Saturday. I'm trying to stream Saturday nights and Wednesday nights. I won't be streaming tomorrow night because I have a friend round and because I've streamed today. So catch me on Saturday night for another stream, and we'll probably be looking at these JL Audio donor boards that I got donated, and that's going to be fun because they're my own. I'll probably have a cheeky glass of wine with that one because that's my own equipment. So